This section, we're going to talk about multiplying whole numbers and then area of polygons. So I'm going to do one video for the first two topics because they're kind of short. So for topic one, we're just going to kind of introduce the idea of multiplication. So as our definition, we have multiplication is a mathematical operation. Operations in math mean addition, subtraction, multiplication, and division for now at least. So multiplication is a mathematical operation used to find the total of one number added to itself a certain number of times. So for example, if we were going to multiply 4 by 3, that would be 4 times 3, and there's different ways we can write 4 times 3. That is equivalent to adding 4 to itself 3 times. Or, interestingly enough, it could also be the same as adding 3 to itself 4 times, okay? So our first example here, it says list 4 ways to express 7 times 3. Well, if we want to think of this idea of multiplication being the same thing as repeated addition, that's what this is right here. That's what this is right here. This is repeated addition. And that's kind of what multiplication is. It's a shorthand way of writing repeated addition. If we had 7 times 3, we could write that as 7 plus 7 plus 7. That's 7 3 times. Or if you wanted to continue with this route of 7 times 3, we could write it as 3 plus 3 plus 3 plus 3 plus 3. That's 1, 2, 3, 4, 5. Plus 3 plus 3. That's 3 times, or 3 added to itself 7 times. 7 plus 7 plus 7 is exactly the same thing as 3 plus 3 7 times over, okay? So you can always think of multiplication as repeated addition, but that kind of defeats the purpose of multiplication because multiplication is sort of a shorthand way of thinking of repeated addition. So instead, we're going to kind of branch away from that idea of repeated addition and just really focus on this idea of multiplication. It'll be a big time saver for us. So for the remaining 3 ways to represent 7 times 3, let's focus just on multiplication. So we could represent 7 times 3 as 7 with a little x and then a 3. You could do 7 and a dot and a 3. You could also do 7 with a little star and a 3. Now, there's also another way that you could write this. You could use parentheses. So instead of doing 7 with an X and a 3, or 7 with a dot and a 3, or 7 with a star and a 3, you could also write this as 7 with a set of parentheses around the 3. Now, this 7 is not considered any kind of like grouping symbol. It's just indicating that we're multiplying these two numbers. It's holding that 3 together, okay? So you could write it as 7 times 3 in parentheses like that. You could do the 7 in parentheses and the 3 in parentheses, or you could do just the 7 in parentheses with the 3 outside. So you've got lots and lots and lots of different ways that we could represent multiplication. So you can use the X, the dot, the star. You're going to see a lot of that at this point. But you'll also see parentheses. So as long as you have two numbers side by side and at least one of them's in parentheses, your brain should automatically think, hey, we're multiplying. And just always remember that multiplication is shorthand for repeated addition, okay? Now we've got 2 more definitions that we need to look at, and those are the different parts of a multiplication problem. So the first definition we have is factors. These are the numbers that are being multiplied. So in that first example that we had kind of written out, we were talking about 4 times 3. The numbers 4 and 3 would be considered the factors. In example 1, we were talking about 7 times 3. Well, 7 times 3 could also be used here, and we could say that the factors are 7 and 3, okay? So that's factors. Now, the second definition that's really important is the word product. So when we're talking about multiplication, the result of multiplying factors is called the product. Okay, so it's kind of like the answer to a multiplication is the product. So you definitely need to remember these 2 factors. Those words are going to come up a lot. So you do need to know both of these. Okay, so for example 2, it says label the factors and the products. Okay, so for part A, we have 15 times 5 is 70. Well, the factors here are 15, I think it's 14, believe it or not. 14 times 5 is 70. So the factors here would be 14 and 5. And then the product would be the answer, which is 70. If we look at part B, we have 12 times 8 times 2 equals 192. Well, the factors here, we have 3 of them. The factors would be 12, 8, and 2. And then the product, the answer, would be 192. Okay, so we haven't talked about a lot, but then in that same way, we kind of have. So we need to know that multiplication is a way of it's kind of like a shorthand way of thinking of repeated addition, okay? The parts of multiplication are factors and products, factors being the numbers that we're multiplying, product being the result we get. And there's different ways to represent multiplication. You can use an X, which we tend to venture away from the X once we start talking about algebra. So generally you'll see the dot, maybe the star, but a lot of times you'll see those parentheses. Remember, if you see two numbers side by side and the only thing separating them is a set of parentheses, that indicates multiplication, okay? Now, for topic 2, we have some properties that are a big part of multiplication. Some of them are kind of obvious, but we're going to go ahead and name them and discuss what they are. The others might be a little newer for us. So as far as properties go, we do have the multiplication property of 0. And just about everybody on the planet understands how this property works. We're just giving it a name now. So we know that the product of any number and 0 is just 0. You multiply something by 0, you always get 0. Never fails, always the case. So if you multiply any number on the planet by 0, your product is going to be 0. Okay? The multiplication property of 1. Again, this is another one where it's pretty obvious. We know what we're talking about. We understand why it works. We're just giving it a name. So the multiplication property of 1 states that the product of any number and 1 is just that number. So you multiply any number on the planet by 1, you just get that number back. Okay? So we've got our two properties so far, multiplication property of 0, multiplication property of 1, and we have examples of each of those. So the example for the multiplication property of 0 is 4 times 0. What is that going to be? It has to be 0. Okay? The multiplication property of 1, 4 times 1. 4 times 1 has to equal 4. Okay? Now, the three properties that are a little bit more involved, two of them you've kind of seen in a different format. So we have the commutative property of multiplication. This is exactly like the commutative property that we saw with addition. The commutative property says that if you change the order of numbers that you're adding, you're always going to get the same sum. The exact same thing is true with multiplication. And we kind of looked at that earlier. So when you're taking two numbers and you're multiplying, it doesn't matter which number you multiply first or which number you have listed first. So earlier we were talking about 7 times 3, and I wrote it out as repeated addition. And then I was like, hey, but this is also the same thing as 3 times 7. And so we wrote 3 plus 3 plus 3 7 times. That right there was me secretly using the commutative property of multiplication. So 7 times 3 is the same exact thing as 3 times 7. You'll get the same product. So if you change the order of what you're multiplying, your product's going to be the same. So the example we have here is 4 times 3. Well, we know that 4 times 3, hopefully we know this, 4 times 3 is 12. Well, is that the exact same thing as 3 times 4? Yes, it's exactly the same thing. You're going to get 12 either way, okay? So that is the commutative property of multiplication. You've already seen it with addition. It works the exact same way, okay? So next we have the associative property of multiplication. We saw this again with addition. We realized that with addition, if we have 3 or more numbers that we're adding, we can rearrange how we group them. So we can rearrange where we put sets of parentheses. And what those parentheses tell us is they're like, they say to us, highlight this, do this thing first, okay? So it doesn't matter what numbers you group in parentheses. If you're adding, group whatever you want, you're going to get the same answer. The same exact thing is true for multiplication. If we're multiplying a series of numbers, we can group them, okay? We can group them however we want. We'll get the same answer, okay? So the property says the way factors are grouped does not change the product, okay? And the example we have here has a typo in it, but pretend with your best intentions that this is not a plus sign, but it's a multiplication symbol. I just caught this. I'm sorry about that. But in this particular case, we have 2, and then in parentheses, we have 3 times 4. Make sure you change that plus to a multiplication. Does that equal 2 times 3 times 4? Well, yeah, it sure does. On the left-hand side, we would want to multiply that 3 times 4 first. 3 times 4 would be 12. Then we would multiply by the 2 outside the parentheses. That would give us 24, okay? Well, on the right-hand side, we have 2 times 3 first. That tells me since that's in parentheses, we want to multiply it to start. So 2 times 3 is 6. Then multiply it by the 4 outside parentheses. Again, we get 24. So just like with addition, the way we group factors isn't going to change our product. Okay, so that's the associative property of multiplication. All right. And then last up, we have the distributive property. This is not going to be as powerful to us now. This is much more powerful when we start algebra, but let's just get used to the idea now. So basically, the distributive property says you can distribute multiplication over addition. So what that means is if you have addition or subtraction, it works for subtraction here. If you have addition or subtraction inside parentheses with a number outside the parentheses, you can multiply. So it's basically saying, if you look at this example, we have 2 times 3 plus 4 in parentheses. Okay. Well, instead of adding the 3 plus 4, let's go ahead and distribute the 2. That means take the 2 and multiply it by each thing inside parentheses. So we can take the 2 times the 3. So we've got that right here. We can take the 2 times the 4. We have that right here. And then we can add each or multiply each piece and then add. So we end up getting 14. Now, we can prove to ourselves this is true. What if we didn't distribute and we just had 2 times 3 plus 4? Well, if we wanted to go ahead and add our 3 plus 4, we would get 2 times 7. And guess what? 2 times 7 is in fact 14. So again, I don't love that we do the distributive property here. It's not super, super useful to us at this point, but it's going to be super useful to you later when you start talking about algebra. Okay, so distributive property, hear it, know it's going to come back. Don't worry about it too much at this point. Okay, so let's practice. Let's see what we can do with these properties. Okay. So example 3 says use the distributive property to rewrite 2 times 8 plus 3. Now, we're specifically doing the distributive property. You don't want to add what's in parentheses first and then multiply. That's not what this is asking. This is saying apply the distributive property, which means take this thing that's outside the parentheses and multiply it one by each thing inside the parentheses. So we're going to take 2 times 8, and then we're going to come right back and get 2 times 3. So I would rewrite this as 2 times 8 plus 2 times 3. And that's really all it's asking you to do. They're just saying rewrite this thing using the distributive property. Again, this property is not super powerful to us at this point, but it will be a huge part when we start talking about algebra. Okay? So that's all they want you to do with the distributive property. Just show the multiplication through that addition or through that subtraction. Okay, now part B says use the commutative property to rewrite 14 times 9. Remember, the commutative property is all about changing order. So if I take 14 times 9, that is exactly the same thing as 9 times 14. They're equivalent, okay? And that's what the commutative property says to us. If you change the order that you multiply or add in, nothing happens. You're going to get the same answer. All right, finally for part C, it says use the associative property to rewrite 9 times 8 times 1. Well, the associative property is not about changing the order. It's about changing the grouping. So the first thing I would do is I would come down here and I would rewrite those numbers in exactly the same order. Okay, I have 9 times 8 times 1. But in the original problem, we had 9 times, in parentheses, 8 times 1. All we want to do to apply the associative property is just regroup the numbers. We don't want to group the 8 and the 1. Now we're going to group the 9 and the 8. We would get the exact same answer. Okay, in fact, if you were to look at this line right here, we would take 8 times 1, which is 8. We know that because it's the multiplication property of 1. Okay, we would then take 8 times 9, which is 72. Well, if you come down here, we would start by looking at the 9 times 8. Well, 9 times 8 is 72. Trust me on that. And then if we take 72 and multiply it by 1, we're just applying the multiplication property of 1. 72 times 1 is just 72. So either way you group these numbers, you're still going to get a product of 72. Okay, so we've covered a lot, even though there wasn't a ton of time spent in this. Remember, multiplication is just a shorthand way of dealing with repeated addition. There are loads of ways that you could write 7 times 3. Okay, we also have factors and products. Factors are the numbers that are being multiplied. Product is the result. So we've practiced factors and products here. We looked at our properties. We have the multiplication property of 0 and 1. We know these things to be true. They're just facts that we kind of know about multiplication. We're just naming them now. We also have the commutative property of multiplication along with the associative property of multiplication. They work exactly the same way they work with addition, okay? And just make sure you fix the little typo that I caught here. I didn't see it until I was working on the problem. And then we also have the distributive property, not as powerful now, will be a big deal when we start talking about algebra.